Okay, today we are going to discuss completing the square with monic quadratic equations. Okay, so what does completing the square actually mean? So I guess the first thing we want to do is just talk about what a perfect square is, right? And you've got me, Mr. C, and you got little David over here, my helper, and he may be asking some questions as we go, or he might be kind of quiet, but it's okay. If we have any questions come up, you can always leave them in the comments, which I will read, and then more than likely I'll post another video that addresses all the questions. So if we look at a perfect square, and we've already talked about this before, a perfect square might look something like parenthesis x, we'll do an easy one, plus 1 squared. So that's a perfect square because it's the same factor multiplied times itself. So if we expand this, we already know that that's x plus 1 times another x plus 1. Okay, and so if we multiply these out, and you can either use the box method or FOIL or whatever method you want, we're going to get x squared plus x plus another x, and then 1 times 1 is 1 at the end. So if we take this and we simplify it, we're going to get x squared plus 2x plus 1. Okay, so for this particular one, that's what the perfect square looks like after you multiply it all out. So why is this going to be important to do this completing the square thing? Well, one reason is that when we have this given to us, we want to make this go back and look like this again for some reasons that I'll talk about later. So the question is now, what would a perfect square look like in general? Okay. So a perfect square in general might look something like this. X plus, and then there'll be some number a times another x plus a. So if we take those two factors and we multiply them together, we're going to get x squared plus a plus another ax actually, plus 2ax, and then plus a squared at the end. So the structure of this perfect square is starting to reveal itself when we multiply them out. We see we get a perfect square here, we get a perfect square here, and we get 2 times that, just the a and just the x in the middle. Is that going to happen every time? Well, it is right now because our perfect square is just a plain x here and a plain x there. Once we put a number in front here and here, it's going to change a little bit, but that's for a different video that we're going to make later. So we look and we see, well, how can we make this perfect square? Well, this number right here has to be squared at the end, and then you just take this times 2, the 2's always there, and you're going to get the middle term. So if we want to find a perfect square, and if we just have an expression that looks like this, let's do x squared plus 2x plus some number k. We don't know what that k value is yet, and we want to know what number for k would make this a perfect square. Okay, and the reason why we're talking about this is going to become apparent in a little while when we start to actually perform the procedure on expressions, or today we'll do equations. So how do we find that k value? Well, we're going to use that structure to figure out that to find the k value, you take this guy right here, this 2, okay? We're going to take half of it and then square it. That's going to be the k value. So k is, right now, k is just standing for, David had a question, what does k mean? K is just standing there for the number I want to find to make this trinomial a perfect square. And I don't know what it is yet, but I'm going to figure out what it is. So what value of k would make this a perfect square? This is what a question would look like on the ACT or on the EOC or something like that. They usually ask this on the ACT. So what we do is we take this 2, we're going to divide it by 2. Why? Because we know it was 2ax in the middle. So we want to get rid of that 2, okay? And then we're going to take that result and square it. that's going to be the k value. So 2 divided by 2 is 1. 1 squared is 1. And we find that we get the k value to make this a perfect square has to be 1. So we have now x squared plus 2x plus 1. That is now a perfect square, even though it doesn't look like a perfect square. So what is the perfect square then? Well, to make this the perfect square, we now have x, and then this number here, positive or negative, in this case it's positive, goes right here, x plus 1 squared. If we multiply that out, we'll see earlier, just a few minutes ago, that we had already multiplied that out, and this is what we got. So therefore, that perfect square now is done, and the k value happened to be 1. Now, if we want to write it as a perfect square, again, you take this number here, and that's the one that goes after the x in the parentheses to make your perfect square. And for monic quadratics like this, it really is that easy. So let's do another one. Okay, so how about x squared minus 6x plus k? So what value of k would make this a perfect square? So again, what we're going to do is we're going to take half of this number, negative 6, square it, and then that's going to be our k value. And the procedure just works the same every time. So we're going to take negative 6 divided by 2 and square it. So we see that if it's an even number here, it's going to already be divisible by 2, and you're going to get an integer over here, which is very nice. Later, we're going to talk about a couple of these where you don't get an even number here, and then you're going to wind up with fractions. But that's coming up. So negative 6 divided by 2 is negative 3. And notice how I use parentheses. Negative 3 squared is positive 9. Notice that's positive. It's always going to be positive, the k value, because you're squaring it. So our perfect square is then x squared minus 6x plus 9. Okay, if we want to write that as a perfect square, it's going to be x. Okay, so what would be the number that will come after x right here? So if you remember, it's going to be this guy right there, the negative 3. So x minus 3 squared is the perfect square. And that's how it works. Okay, now let's see one where this number in the middle right here is not an even number, it's an odd number. Okay, so let's do this time x squared plus 3x plus k. All right, so this time you're still going to do the same thing. You take the middle number here, 3, divided by 2, and then square it. Well, when you square this fraction, and we don't want to really turn this into a decimal. There's no decimals up here, so it's always better to leave your answer or your numbers as rational, a fraction. So if you square 3 halves, it's just 3 halves times another 3 halves, or 3 squared over 2 squared, which is going to be 9 over 4. Well, that's your k value. So our perfect square is going to be x squared plus 3x, and then plus 9/4 at the end. Now that 9/4 right there is going to make a lot of people uncomfortable because it's a fraction, and we know how people hate fractions, but it is what it is, and that's what is going to happen. If you want to write your perfect square, it is now going to be x, and then, of course, I'm going to ask what number comes after x. It's going to be the 3 halves this time. Okay, it didn't simplify, it just squared. So that 3 halves now is coming behind the x right here, x plus 3 over 2 squared. Now I would ask you to go ahead and take this, multiply it times itself, and then just make sure that you get this back. That way you're confident that you did it correctly. All right, so now we're going to move a little bit forward now that we know how to do this. And we're going to see how to actually complete the square on a trinomial or a quadratic to solve an equation. So now, this is where the real fun begins. All right, so we're going to solve. And this time we're going to do x squared plus 2x minus 3 equals 0. All right, Now, there's a couple ways we could do this. This is my favorite way because students tend to understand this more. This time, we don't really want it equal to 0. We just want these two terms to be on the left-hand side. So this guy is going to have to go over here. So I would encourage you first to add 3 to both sides. So the problem we're looking at now is x squared plus 2x equals 3. And notice I left a little space right there after the 2x because this is what I want to complete the square on. I want to find that value of k to put right here to make this a perfect square. All right, so what value would that be? So we have a 2 in the middle, which is even, and that's nice. So we're going to take 2, divide by 2, always divide by 2, and square it. So we get 1 squared, and that equals 1. Okay, so that number is going right here. So x squared plus 2x, and then plus 1 equals 3. But I did something wrong here. If I leave it like this, I did something wrong. The thing that I'm going to do wrong, if I'm not careful, is I added a 1 over here. Now this equation is going to change if I just add 1 to this side, but not that side. So this is what you have to make sure you do. Whatever you do to this side, you have to do to this side also. So this 3, we're going to have to add a 1 to it over here. Okay, and now it's a perfect square on this side, and this side is now balanced. So now we have the equation with the same solutions as it started with. All right, so here we have our perfect square, which we're going to write now as x, and then what would it be? X plus what? What do you think, David?
1.
Yep, 1, because 2 divided by 2 is 1, and there it is. That number goes here. Squared equals, and then 3 plus 1 is 4. So now we have done these previously, and we already know how to solve this using the square root property. So I'm going to do that real quick and see. So you see now what the purpose of completing the square is. You can take this, which should be somewhat difficult, and turn it into something we've already done, and it's now familiar. So let's do that over here. X plus 1 squared equals 4. Okay, first step, we're going to take the square root of both sides. The x plus 1 drops out, and then we're going to get a plus minus root 4. Well, the square root of 4 is 2, so now we have x plus 1 equals plus or minus 2. The 1 to plus 1, we're going to add to both sides, subtract from both sides. X equals negative 1 plus or minus 2. And so we're going to get the two answers, negative 1 plus 2, which is?
1.
1. And negative 1 minus 2, which is?
Negative 3.
Negative 3. And again, it doesn't matter how you write these in the curly brackets, what order, it just needs to have them both in there. And there's your two solutions. So this procedure right here seems a little complicated and overwhelming at first. So what we want to do is we want to break it down step by step, and then we also need to know why we're doing this, and that is to solve that equation. Later, we'll take some functions, and I'll show you why we're going to actually take the function and do the completing the square, which is a little bit different purpose. All right, so let's go ahead and do another one. And this one is going to be solve, and I'll write the word up here, x squared minus 12x plus 36 equals 0. All right, so the first thing we want to do is take that 36 and move it over to the other side. So we only have the x squared minus 12x over here. So x squared minus 12x. I'm going to leave some room over here for my perfect square equals negative 36. All right, so what I'm going to do now is I'm going to take that negative 12. I'm going to take half of it and then square that. Well, negative 12 divided by 2 is going to be negative 6. Negative 6 squared is 36, which is interesting. So that's the number that's going to go right there that we used to call k. So plus 36. But again, I have to add 36 to both sides, which makes things kind of interesting here because this is now going to cancel out. So now I have x squared minus 12x and plus 36 equals 0. Interesting, because that is what I started with. What does that mean? If I got the same thing I started with back here after I did my procedure, what would that mean?
You repeated.
I repeated?
You
What do you think, David?
you got the same answer.
I got the same answer. I got the same thing back. That means that this was a perfect square already to begin with, wasn't it? So now I know exactly, I didn't waste my time because now I know that is the number I need behind my x. X minus, let's get rid of that. X minus 6 squared equals 0. That one's actually easier. If I go ahead and I take the square root of both sides, I'm just going to get x minus 6 equals plus or minus the square root of 0, which is 0. X minus 6 equals 0. And so when I move the 6 over, there's only one answer. X equals 6. Well, what does that mean if it has one answer? That means that that particular quadratic, the graph of that, if it was a function, would come down, it would touch the x-axis at 6, and then come back up. And so there's only one answer this time. And we've talked about those equations that only have one answer, and that is exactly what happens. The graph, make a quick sketch, at 6, will come down, touch, and go back up again. It is important to match that picture with that solution and the equation also. So, let's go ahead and do another one. And let's keep it fairly simple this time. Let's do solve. And let's do x squared plus 4x minus 21 equals 0. All right, so I'm going to go ahead and move the 21 over. X squared plus 4x. Leave room for my k value there. Equals positive 21. All right, and I always write this out. I know some students like to do it in their head. I don't like that. I like to write it out. And so I need that 4 divided by 2, always divided by 2, squared. Equals, now 4 divided by 2 is 2. 2 squared, and then 2 squared is 4. So that's the number that goes right here. So plus 4. And then plus 4. All right, so down here now, I have x squared plus 4x plus 4, and I know I'm rewriting that, which is fine, equals 21 and 4 make 25. Okay, this is now a perfect square, and it is x plus 2 squared equals 25. All right, so now I'm gonna wait a few seconds. I'm gonna let you go ahead and solve this, and then I'm gonna solve it over here and knock it out. So I'm gonna give you about a minute. All right. I know some people work fast, some people work slow. You could always pause the video. All right, so let me go ahead and knock this out over here. So the first thing I'm gonna do, I'm gonna go ahead and write it again. X plus 2 squared equals 25. Take the square root of both sides. The x plus 2 drops out, equals plus or minus, and the square root of 25 is gonna be 5. And I know I'm skipping a step there, but I think you guys have followed along by now. I'm gonna move the 2 over. X is equal to negative 2 plus or minus 5. Okay, that's gonna give us two solutions. Negative 2 plus 5, which is 3. Negative 2 minus 5, which is negative 7. All right. Now, interesting side note, if you get two answers that are integers, here, what does that mean? That means that this original equation could have been factored right from the start. X plus 7, x minus 3. And it's okay if you want to solve something like this by factoring, but if they do ask you to use completing the square, you have to use that strategy because that's the assessment that they're trying to make to make sure that you know how to use completing the square and you're not just doing everything some other way. All right, so interesting enough, let's go ahead and I'm now going to pick one that has an odd number in the middle. Okay, this is going to be a little more fun because I know how you guys love fractions. So this time we're going to solve x squared minus 7x plus 12 equals 0. Now, are we always going to get answers that are rational or integers? No. You're going to get answers sometimes that have radicals in them, square roots. It's very common to have that happen. Normally at the beginning of a lesson though, we will give you problems that have nice solutions so you feel comfortable and confident, so that way we can kind of move you into those other ones that are a little stranger after you've developed a good handle on the solution process. So this one, we're going to go ahead and take that negative 7. Well, first I guess we'll have to move the 12 over. So x squared minus 7x, I'm going to leave some room here, equals negative 12. All right. I got to take half of the negative 7, and I know at first that's not going to look very nice. This is actually going to look worse. We're going to square it. After you square that, you're going to get a positive 49 over 2 squared is 4. Yep, and so when this happens, you just got to deal with it. So plus 49 over 4, and then guess what? You got to add it to the other side too. And now you're really not going to like that. But there's nothing that says you can't handle this. So let's see how it works. So this side over here is now a perfect square. And actually this time I'm going to simplify it from this step to the next. So we have a perfect square x. Okay, what will come after the x? That number right there, negative 7 halves. Minus 7 halves squared equals, okay, now 49 over 4 and then take away 12. Well, 4 times negative 12 is negative 48, right? Mm-hmm. Plus 49 would be what, positive 1? Mm-hmm. Okay, so you got 1/4 on the right-hand side. Now, don't freak out because it's a fraction. It's going to work out okay, I promise you. All right. Now, you're going to take the square root of both sides. Okay, so when we take the square root of both sides, this pops out, x minus 7 halves. It's okay. Equals plus or minus. Now, with the square root of 1/4, square root of 1 is 1, square root of 4 is 2, 1/2. See, so I told you everything was going to work out okay because we got the same denominators here. Now, when you solve this, x equals, you got to move the negative 7 halves over, make it positive 7 halves, plus or minus 1/2. See, everything's going to be okay. We're going to get two solutions. 7 plus 1 is what, David?
8.
Divided by 2?
Is 4.
Okay, so 4 is one answer. 7 minus 1?
6.
6 divided by 2?
3.
Okay, so life isn't too bad. 4 and 3. What does that mean? Well, that means we could have actually taken this original equation and solved it by factoring, which, yeah, it would be easier, but we still need to know the process because these are going to eventually get tougher. X minus 4, x minus 3 would have been the two factors. All right, so that's it for the lesson. I'm going to go ahead and send out a problem set, and please feel free to leave comments or anything like that in the comment section. And from David and David, we'll see you later. Happy computing.